Okay, this is a homework help video for Unit 2, Worksheet 3, and I am going to start with question number 2. So we have to first accurately graph f of x and g of x, so that's going to be our first step. So f of x is y equals -2, so for y equals -2. So there's no start, no stretch. So I'm just going to go, this is a special case, I'm going to go to where y is equal to -2. And then it's a horizontal line. So no start, no stretch. So there's y equals -2. And then I want to graph my other one. So g of x equals -x. So g of x equals -x. So g of x is the same as y. So my start point is 0, 0. I'm not adding anything to x, adding anything to y. So my start is at 0, 0, which is the same as my vertex. And then my stretch or my slope is -1. So then I'm going to go down 1, right 1, and then reflect it down 1, right 1. And then I'm going to use a straight edge so that I can graph this accurately and find my intersection points easy. So this is G and this is F. Okay, so now it's asking me to highlight the portion of f of x. So that means I'm going to highlight something along the blue. So if I want to highlight f of x, so I'm going to circle this so that I know when I highlight, I'm going to highlight whatever is on that line. Okay? And I want g of x to be greater than f of x. So that's kind of confusing because I'm highlighting on f of x. So I'm just going to rewrite that equation. So this is the same thing as saying that f of x is less than or equal to g of x, right? So all I did was flip that around so it makes more sense for my highlighting portion. So I want to highlight on f of x to where f of x is greater than or excuse me, less than or equal to g of x. So when will this line here be below this line? And that's this section right here. So I'm going to mark my intersections with a closed dot because of the equality, and then I'm going to highlight the section in between. Okay? And so then now it says to state in interval notation where that's happening. So this ordered pair right here, so that intersection is at -2, 2, -2, -2. And then this intersection here, I'm counting over 1, 2, and then down 2. So that intersection is at +2, -2. And then whenever I do interval, I'm doing beginning x value, ending x value. So my beginning x value is -2. And then my ending x value is at +2. And then because of the equality, it will be brackets. All right, and so now for part B, they're asking us to solve algebraically for g of x greater than or equal to f of x. So here's my g of x equation. And then greater than or equal to f of x, which is -2. So the first thing I want to do always is isolate the absolute value. So I'm going to divide both sides by -1. So then I have the absolute value of x, and then -2 divided by -1 is +2. And whenever I multiply or divide by a negative, I need to switch the inequality. So then now I need to make two equations because I don't have a special case, right? It's not negative. So this is a less than. So less than is and, right? Less than and. So I'm going to have x is less than or equal to 2 and -x is also less than or equal to 2, right? Less than is and then solve the equation. So this is already solved. So over here, I just need to divide by -1. And whenever I multiply or divide by a negative, I need to reverse the inequality. So that would switch to greater than or equal to -2. So then x is less than or equal to 2, and x is greater than or equal to negative 2. Okay. All right, and then let's go to the back side. Okay, and then let's take a look at number 6. So step 1, we want to isolate the absolute value. So I need to get rid of the negative 1/2. So I'm going to multiply by the reciprocal, which is negative 2 over 1. And then negative 2 over 1 is the same as negative 2. So I'm going to multiply this side by negative 2. And then this reduces to 1. I multiplied by a negative, so I need to switch the inequality. And then 10 times negative 2 is negative 20. So this is a negative number, so that means I have a special case. So when I think about this, I say, okay, I know these are always positive, so when is a positive number greater than a negative number? Is that always or never? So is a positive always greater than a negative, or is a positive never greater than a negative? And it's always, so then that means that it's all real numbers. Right? So regardless of what x I choose, I will always have a true statement. Okay? All right, and then let's take a look at number 11. Okay, so the absolute value is already isolated. Okay, so then I'm going to write two equations. So then I have 5 minus x is less than 6, or excuse me, 5 minus x over 6 is less than 2. Less than is and then 5 minus x negative is also less than 2, right? So less than is and, so I have two equations, so the positive version and the negative version. So to solve for x, I want to multiply both sides by 6 to clear my fractions. And then subtract 5. And then divide by a negative 1. And I divided by a negative, so I'm going to switch the inequality. Okay. And then I'm going to do the same thing over here. So I'm going to divide by the negative 1 to move it over to here. So then I will get 5 minus x over 6, dividing by a negative, so switch the inequality. And then I'm going to multiply both sides by 6. And then subtract 5. And divide by a negative. So then switch the inequality. Okay. So for these two right here, so I'm going to put these two together down here. So x is greater than negative 7 and x is less than 17. Okay, so I'm going to go ahead and I need to write this in interval notation. So I'm going to graph it first so I can kind of see what we're talking about. So I'm going to mark negative 7 and 17. So I know that it's strictly greater than, so that will be an open dot. And then greater than, so to get to greater values of negative 7, that's going this direction, right? So going that way. But it also, because and, has to be less than 17. So open dot here as well, so going that direction. So that means the solutions are all of these numbers in between. And then to write my solution in interval notation, I say it is between negative 7 and 17, and then it's not equal, right, because of the strictly less than, greater than, and then open dots. And that's the answer to number 11. Okay, and then we're going to do one more here. We're going to take a look at number 14. So step 1, isolate the absolute value. So I'm going to subtract the 4. So for this one right here, so I have a negative number, so that means I have a special case. So I know the absolute value is always a positive, and then this is a negative. So then I ask myself, is it always or never? So is a positive always greater than a negative, or is a positive never greater than a negative? and it's always, right? A positive is always greater than a negative. So then my solution would be all real numbers. Okay? And then in interval notation, so all real numbers would be from negative infinity to positive infinity. And then for graphing, it would be everything on the number line. Okay, and I realized I forgot to do that up here on number 6 as well. So this should be also negative infinity to positive infinity. Okay, and that's homework help for worksheet 3.